Hi, Mark. Welcome back. The last time we was in the episode 38 about with the title Apache Firefighter. And back then, we wanted to talk about microservices because you love them. And you say, okay, let's talk about them because any reasonable application should have as many microservices as possible. This was my understanding back then, right?
Not really. So the point is, people are most of the times not aware of the trade-offs, and they kind of, the old saying with the hammer and the nails from Paul Watzlawick, I think, from the philosopher. If you have a hammer, every problem seems to be a nail, and it's kind of a discussion. I give a university lecture about it since many years about hype-driven development.
Oh,
and
okay.
the topic morphed a little bit from NoSQL to cloud and big data, and in the last 4 or 5 years it was about microservices. And when I gave this talk the first time, also at conferences 4 or 5 years ago, people really had funny looks because, oh, hey, what's he talking about? Everybody's raving about microservices. Why is this guy trash talking? And the point is, I'm not trash talking microservices, and I find them really, really good for a few certain problems or scenarios, but it's not kind of the silver bullet for every business problem, especially for in-house projects. And people are most of the time just, they read the topic in computer magazines or hear about it on conferences, and then they use it and go all bonkers. And some technicians start with it because it fits for their project really well, and then they spread it, or kind of, they're doing this with their heart because it really fits really, really well within their project. Like, for example, Netflix, where microservices is really really well fit. And people see this and say, oh, well, I love this. This should work for my project as well. I need to try this out. And the truth is that often the scenarios are really a lot different than with kind of Netflix style applications.
So the scary part here is what we are talking right now. This is what I also did on my recent talks. So I already mentioned, Netflix was already on my slides, and I'm actually absolutely with you. And that's interesting because we never had a chance to talk directly at conferences or just said hello. And for me, the first thing. So how microservices started. So if when was it? I think 6-7 years ago. I started to see, the term microservices, and then I tried to look it up, and the people already had to discuss what is a microservice. And what I remember is there was discussion how many lines of code a microservice should have, and I say, okay, this is absolutely stupid. I mean, because what does it mean? So if I have 50 lines of code, I'm in microservice area, and 51 I'm already somewhere else, and the whole discussion was never about at the beginning. It was more like, we write a small microservices and they communicate via the Unix or Linux pipe with each other. And this was the idea. And I said, this would, I couldn't even imagine this would never fly in my projects. And the whole discussion was not about, added value for the application. More like, there is a new term, microservices. And already, what you already said, and let's now just use it somehow. So this was my perception at the very beginning. Remember this?
Yeah. There is a huge added value. There are 2 or 3 added value, because people didn't do this out of the blue. They did this because their old applications, kind of monoliths, they kind of developed for 15 years or so, and they grow for 15 years, are barely maintainable right now. But the point is that often this is not because of being a monolith. It's just because being 15 years in maintenance and people adding things here and there, and the original people are not available anymore for a long time. And so this went through 100 of hands without understanding the full complexity. And this is most what makes monoliths so badly maintainable. They just grew over the years. And if you would do a monolith from scratch and, for example, use Apache Maven to have I know you're not a big fan of interfaces, but for this scenario, it's really cool if you have an API module and a backend module. So you split up your application in business parts, like you would do for microservices. And then each of these business parts has an API, a backend, and, for example, a front end, jars. And then you only have a compile scope dependency on the APIs, on the interfaces and DTOs. And all these backend modules are just runtime dependencies. And with this trick, you can really well structure a monolith as well at compile time. At runtime, of course, it will be a monolith and also a deploy time. But it's really much more maintainable. And you get similar effects than you get with microservices. But you also have to take care, because if you have all in the same source code, then people kind of hand over to the other module where they actually are not responsible for and change some code there as well. So it needs kind of some, so people have to understand as well what they're doing, but you don't have the network boundary, which gives you a few benefits in the performance and also in the transaction mechanism. But people didn't do monoliths they had a real pain. And the real pain was modularization, which you of course could do, as I already explained. And the second thing was that it's just sometimes too big. If you have a huge company and you have 100 developers, it's really hard to do this all in one source code.
Okay.
And then, of course, you need to split.
Let's talk about modularization. So what I see in projects is sometimes what you exactly said. So funny story aside, I had to review microservices or not microservices. Mm-hmm. It was like war projects, which supposed to be somehow modular. And my clients ask me, how much time do you need? It's like, okay, 2 weeks. So I will manage to perform the whole review. And I got the 2 wars. And what I found out that inside the 2 wars were in total 120 Maven jar modules. And they were actually structured, as you said. So from the, from the crafting level or from the developer knowledge level, they were perfect. So it means there were modules, Maven modules, just with API level interfaces, and there were implementation Maven modules, and there were service providers and service consumers. So it was more like textbook project. It was perfect, but
moduliths.
Yeah,
that was a term I recently read.
But it was not maintainable. Everyone hated that, and I needed 4 weeks for the review, not 2 weeks, because I actually always forgot what I actually saw. And I had a killer argument against the architect, why the architecture was wrong. Can you think of how to tell the architect that the whole thing is useless? Very easy, actually. What I did, I took a look at the versions of all the modules, and they had always the same version.
Oh, that's because they are build time, one project. And I understand this because it perfectly fits together. It's also a trade-off. If you build all at the same time, then you have the benefit of being able to say, the customer topic or the customer domain is in this module and nothing else touches the core customer update domain. They can read from it via the APIs, but they should only change the customer itself in this module. And there is the billing domain, which is in another module, and so on. So you have clear dependencies, and different teams can work on this.
Yeah, but
different.
They never had to know.
If you build it in one big fat Maven project,
exactly,
then you are guaranteed that it all fits together perfectly well.
Yeah. but they always had this inversion. So it means they never had the case in the whole history of the projects where they released, the customer independently from the other module.
I think that's fine.
For me, it was,
And
But
the point is, you are 100% sure that you have no dead code because you can analyze it with standard tools. You compile it, and you're 100% sure that all the APIs fit together, and so on. So it's not always, in my opinion, required to. It's the next level of you have different areas. You can say you split the domains in different models. Then you can say, oh, you make this reusable and split this into own Maven project with their own version lifecycle and release lifecycle. But that's the next step already. If they say the customer is really that stable, they don't touch it for months and so on. But once they touch it, they have to upgrade all the downstream projects. And the same is with microservices. And of course, you can try to keep the versions or the APIs compatible, but actually that's in big projects, that's always some pain point because you need this to test this in a staging area. And most of the time you only get the failures at runtime then. If you figure that something is not that compatible anymore. So you it's just like moving to JavaScript kind of thing.
Yeah,
so
but
you leave the area of static compile checking and go more to the runtime failure handling.
But again, what they did, everything was built at once. So all the 120 modules were never built, for itself. They always built the whole thing.
This is depending what you need. This is a valid approach in my eyes.
Okay, the next level
is not an hour. So
you would be harder to convince than the architects. I see already. But the next level was all interfaces had exactly one implementation, and there was never two.
It's also from. Yeah, it depends from the sanity. No, the point is that you have the contract. I'm coming from C as you.
Yeah, I know. I as well. But it's interesting discussion.
You had the header files and you have the contract.
Exactly.
And also, I don't have any Java docs except in the APIs. Or not any. Yeah. I have Java docs if I do some really tricky technical or domain trick where the business logic is not that intuitive, and you could write the method with 130 characters to explain what it does, or you just write a smallest Java doc.
Yeah.
But usually the implementation does not have that much Java doc, but the APIs they have, and all my unit tests, for example, they test solely against the APIs.
Okay.
And not the implementation.
To ask you, what are you actually building? As a client projects or server services and technical stuff? What are you talking about?
Most of my projects are business projects, which are used internally. So
hopefully we won't meet in a project. This would be fine, for forever. You will write the interfaces, I will delete the interfaces, and but it's fun to talk about it.
The point is, I see the interfaces as a contract. And they are well defined. I think my unit tests, I do the unit tests interface first. So it's not exactly test driven development in a pure way, but it's close to test driven development. So I think about how would I model this domain? How should it be used? Then I write a few unit test bodies where I have the use cases, and I start just writing unimplemented interface methods, how it should feel. How would I love to see the API? How should it behave? What state do I need? What data objects do I need? And I play with this. There is no single line of implementation for it yet. I just play around how the API feels. Mm-hmm. And this is the interfaces, just the interfaces, no implementation.
This is interesting. What I do,
then I fill it with Flash and Meat.
Yeah, but what's interesting in our conversation, I am exactly the opposite. So, and I think this could also work. So, what in my projects, actually, in the recent years, I don't remember I wrote an interface. Probably, sometimes with Java 8 interfaces with static methods, so like utility, something like this, but not as a contract. And but I'm just talking exclusively about Java EE and microprofile projects. The approach would be completely different in Java SE. So in Java SE, I'm with you. I'm talking about Java EE. And what I'm trying to use as much as possible is the conventions from Java EE and CDI, let's talk. EJB or CDI for me is the same almost. Yes. And for me, the contract are public methods. So I do exactly what you're doing. I'm starting with a POJO without an interface, and public methods matter to me. And JavaDoc is on the public methods. And private methods or package private, I do not allow private actually. I have package private or public. This is this. And with the package private are private actually. And why they are package private? Because it's easier to test without any tricks. So, and from that, I don't also have DTOs at first. So I can expose or I allow, or actually I promote the direct exposure of if we have JPA, let's say JPA entities with let's say JSON-B, and I write system tests. So for me, the unit tests are just for productivity, and the black box tests or system tests are the most important thing in microservice-like architectures. So, and from there, if I find that, let's say, that the contract of the POJO is too weak because we would like to encapsulate algorithm or whatever, then afterwards I introduce the interface with a proper name. And if I find that, let's say, the annotations and are on JSON-B are not good enough to transfer different view as the database provides, then I introduce the DTO. So what might happen is that we both end up in exactly the same code, but after a few iterations. But you will start, with the optimum, and I'm starting with the minimum. And why? I don't know how you are working, but I always have to work, with people who I don't know. They come, from different companies, and everyone try to show off what is the recent architecture. And introducing interfaces, factories, and patterns is very easy in my project. So if I will tell, let's build, 5 layers, everyone would be happy. But then it ends up, in a cargo cult where everyone builds pattern whatever they can, and they forgot about the business logic. So I think the only chance I have to build something reasonable, to build as simple code as possible. So this is why I find it interesting that we both probably end up having the same code, but the approach is completely different.
I think we have to, I now opened an editor, and I will kind of, like I do if I'm at conferences or at political discussions or whatever, I kind of always have pen and paper with me to, but you was too fast kind of bit. So I agree with you that we probably both aim for the same end result. And there's another point where I completely agree with you that pure unit tests are more or less they don't make that much sense, and I also try to avoid heavy mocking, because you end up testing your mocks and not your real code. And so that what you name business tests, what have you coined it? Business tests?
System tests.
System tests, yeah, kind of, yeah. It's kind of a slow integration test. I do pretty much the same with, I start a container. There are pure unit tests, but a pure unit test,
How you start the container? How you start the container?
With Delta Spike CDI control.
Okay. This is the next difference. Delta Spike, Archelian, and whatever are forbidden in my project.
Yeah, okay, that's.
But why?
Why?
Yeah, exactly. Because what?
Okay, let's stop. And between each test, I just kind of kill the scopes. So every session scope, request scope, and so on is kind of flushed. So there is no contextual instance over between the tests. It takes nanoseconds. And then the container starts only once, and then you kind of run through all the unit tests and just kind of flush the brain of the CDI container in the sense of the context. Everything else is there, and I mock the outgoing. So if you leave the system, all those things are kind of mocked with CDI mocks. And all the rest is kind of using the business logic against, for example, a H2 database. So I really test with the database layer in business projects. There's a huge difference if I do tool projects like Delta Spike itself, or like, I've written kind of the Java E container inside core things, and there it's completely different because you need different scenarios. For business tests, I most of the time have exactly one scenario, which is my standard business scenario. And there I have a few hundred business cases or 1,000 business cases, and they need to run with exactly this one setup. So boot the container once for my module, run all the unit tests. So I only have the container overhead 300 milliseconds or so once. And between the unit tests, it takes no time because it's just kind of clearing a map. Okay. That's it. There is no performance hit once the container is started. And it gives you the benefit that you really test the whole thing down to the database.
Yeah.
And the most of the problems actually are in the database layer. And JPA does a wonderful job to abstract away different databases, but if most errors in my experience is from database handling level.
Interesting. Complete different approach, probably similar results. So let's take that.
Mm-hmm. I would love to go back to the question about we scratched this question: how big should a microservice be? And I would kind of claim that microservice is a name, but actually it's about modularization on a code level, and we have been there with SOA. We have been here with remote HEPs where
Genie.
Actually, for example, it's all the same. It's about you have a computational problem and you want to split it out to a different isolated box or a remote thing.
The discussion with you about modules is even more interesting than microservice. So then I would like to hear your opinion about Delta Spike.
Microservice is just a name.
Yeah.
Of course,
but the approach is completely different. So, for instance, why I forbid Delta Spike, CDI unit, and Archelion, and the reason for that is, again, I work with developers who try, So, whatever you said is reasonable if you are working with experts, and I think you are working with in small team, and then it might work. In my projects, for instance, most of the tests are written because the developers need metrics. And they would do whatever they can, to have a high code coverage, regardless whether the tests are reasonable or not. So therefore,
okay.
No, really, no kidding. This is 80% of big business projects operate exactly the way. The first question is code coverage, because they need Sonar in Sonar Cube in default settings, and they need the metrics. But what I wanted to say is, for instance, database tests I do completely different. For instance. I have the JPA entities, and I boot with persistence create entity manager factory and pass the persistence unit. Then the next line is entity create entity manager, and I have the entity manager, and I look at the application server, and I use exactly the same SPI. So let's say Eclipse Link or Hibernate version, or OpenJPA version, what the server is using. And then I iterate very quickly because I can test all the named queries up front. And now something happens interesting. Now what I'm doing there, so I'm writing the named query first. I put it in annotation on the entity. And sometimes from there, I write the method in a unit test, the query method, and then I copy the methods to a controller class or service class, and it becomes my POJO. You know what I mean? So I write a test first, and then almost test-driven. I don't like the term, but
that works for the first iteration. But how about maintenance? If you get an additional field, then
the next thing is then for instance, most of my clients have, for instance, OpenShift or Docker. So bare metal is almost no more existent. I have to say, the last years was Docker or OpenShift, or Kubernetes. So in Docker case, what will happen is we have a continuous integration pipeline, and I would force the developers to push as often as possible, and then we will run through system tests. It means what you are doing in CDI, we would do in production near environment. This would be my requirement. And in OpenShift, I will prohibit use Docker Compose or Docker locally, because what I saw several times is that developers build their own environment locally and never actually deploy to Kubernetes, and it actually never runs. And what I would like to achieve with that, with the system tests, we are forced, to test not only the Java part, but also, the readiness, liveness probes, and the whole thing all together. And because if we would do what we are doing with CDI in my projects, no one will, push to the CI anymore. They will just play with the CDI unit or Delta Spike or Archillion. And for me, if we don't have time, the most valuable test is production-like tests, and therefore I go with that. So in one project, and different scenario, I was once hired by Vardin to integrate with Java E6 back then. It was a long time ago. And I had to introduce my own CDI scope. I think it was like tab scope or view scope. UI scope or something like this. And it is really hard to test that. So what I did, I used back then Archillion, and everything was Archillion tested, because the whole point of the project was implementation of scoped and dependency injection. So this was something like, Delta Spike or Archillion was golden, because it was the whole point of that. So this was just, what we are doing, and this works well. And at least everyone, spends a lot of time in integration environment and not an own machine. And locally we use, let's say, an IDE with a plugin which automatically deploys to the server.
So you now have kind of 3 or 4 different things which I kind of wrote down here. The first is Docker, Kubernetes versus bare metal. And in many of my projects, it boils down to what people need, and what we do usually is Kubernetes comes with a lot of overhead.
Yeah.
And there are 2 different projects, in my opinion. Projects which need scaling and projects which don't need scaling. And the projects who need scaling is really a well fit for cloud and kube and things like that, which the whole point is about being able to scale. Also for Netflix, the example I give in my talks is on this Christmas Eve, you have 1,000 times the traffic on Netflix like on a Saturday morning or a Tuesday morning under the year. So they kind of can scale up dynamically, and then after they don't need it anymore, they kind of shut them down. And for them, Amazon and so on makes sense. But if you're like an insurance company or a pension fund, where the people come to the office at 7 in the morning on Monday, and at 5 o'clock in the afternoon, they all leave the office, and this goes Monday to Friday, 52 weeks a year, and you have the requests are the same over the day, then there is no kind of need for scaling. And what we do is to use something in between. We, most of the time for those projects, we use KVM. So Linux kernel virtualized machines, which is way faster, 40% faster than Docker or Kubernetes. No abstraction layer. You have kind of almost the bare metal speed, but if something goes bonkers, you just kind of duplicate the KVM, and you can upscale a node on the fly or move to another box on the fly, because it's kind of the KVM is on some NAS, and you can kind of take it over to a different machine. So it's not as dynamic as Docker, but it's good enough for production if you have a stable load. Mm-hmm. So this is, and you have much better performance.
I'm completely with you.
And much more maintainability.
I'm completely with you.
The only thing you need to take care is that the administrators don't do kind of manual tweaking, because then it's kind of nasty thing. So you have to kind of have some Chef or Puppet or like they check in their config into Git or Subversion or something like that. And you have to train them a little bit. The second point was about production tests, and the downside with this approach is that you always have a staging area, and you never know if your test fails because your thing is broken, or some colleague just tried something out as well and broke your integration test. So you have it's randomly broken, and if things are randomly broken, people start to not taking care anymore. because, well, it won't be me. My thing will be fine. It's someone other broke the staging environment. So I try to do a little bit more on the kind of local integration side testing, but totally understand your notion. And the truth is somewhere in the middle, I guess. So like many developers, one of the projects I'm currently working for has 138 developers, and they are split in smallish teams where there is at least one person who really knows what he is doing, or rather pretty much knows what he's doing. There is a group of a platform team, which is kind of on my level. So they are really, really okayish. And then you have a few kind of the people who make the work. So they are good business developers. They understand what they're doing, but they are no experts. And then you have two kind of juniors. So the teams are kind of mixed, and with that you can kind of work pretty well also in a rather bigish project, but it's probably that way because we trained him for many years, and it in the beginning it was probably more like you, that the main difference between your projects is that you get kind of hired for being a kind of a spike solution and kind of come to the customer for a month or so and help them and kind of try to get rid of the most ugly parts. And I usually kind of be with a customer for many years, once a week, twice a week, and kind of guide them over a really long-term time.
Exactly.
So
this is what I wanted to say. So sometimes, I have no influence. So the Kubernetes or OpenShift is already there. So I remember in only in 2 cases I advise to introduce OpenShift or Docker. In all other projects it was already there. So
it sometimes makes a lot of sense, because especially if you're kind of you're trying out a new business and you don't have a clue how much load you will get if this takes off, or you say, "Oh, scrap it! I don't even buy an own box for it."
No,
so
this is not about load.
It might make sense.
In most cases, it's not about load. It's about how to call it, like sysadmin productivity or maintainability. Because if you just would run Docker containers, you will have, to introduce your Docker networking and care about the port conflicts and whatever. And Kubernetes automates that. So I hear at conferences, lots of talks about scalability, and this is really boring topic because I think in most cases database or I/O is the problem and not our containers. So in
business process,
this means we never scaled because the application servers are fast enough. But with Kubernetes, what you really can, or OpenShift, what we for instance do, one command and you have your Jenkins with pipeline. Another command and you get the route, everything is set up. So it's extremely productive to get new environments. And what you said with KVM, I would even go a step further. So I think the most optimal solution would be a small bare metal boxes with fat jars on them. And this would be the optimum, that you have a small, inexpensive pods of hardware and then and do it this way. And KVM is like the expert level. But KVM is not as known as, as Kubernetes or OpenShift. So my clients wouldn't get the answers on Stack Overflow. So I mean, this is
it's the whole Red Hat virtualization engine is based on KVM. So kind of you have already KVM if you're starting Red Hat virtualization.
Yeah, I use this on my server. The cool story with KVM is this: they also have the COV, this copy and write file system, which is very similar to Docker. So there are books on everything, but it's not as popular. So for me, would be a lot harder to introduce than, let's say, OpenShift, Docker, or Kubernetes. This is but we're right. Kubernetes is a complex beast, and it is you've worked properly with Kubernetes already. So it is like absolutely, if you start with it to say, okay, this is like what is it? I have to send YAML files back and forth, it's completely different to anything else. So, but interesting part. So, and you are also absolutely right. You stick in a project longer, and I in several projects sometimes view days and try to fix something or I try proof of concepts or strategic consultant, whatever. They ask me, "No, what is the future of this? What we can do? Proof of concept, or something like this." This is what I'm doing, and so
What
different.
is your most pressing problems you see at customers? Because I have an answer for this already, but I want to hear yours first.
Overengineering. This is why.
Okay, yeah.
Why I don't like to hear your solutions with the interfaces, because if I will propose that, it would explode. You know?
Well, I only suggest this if I know the business is huge.
Yeah.
And then for smallish problems, isolated problems, it's complete overengineering. But if you see kind of old COBOL applications like of big banks, and so they want to move from one to other, then it's often a really good fit. And this comes to my number one problem I see, is that people always just care about the sunshine case. People don't think for failures. People engineer code for the green path, like the optimum path for their business, without any error handling, without any exceptional cases. And they don't think about what could go wrong, and everything which could go wrong, even it's in a 1 to a billion, chance, sounds like incredibly low. But if you know that, I mean, we have boxes which run 4 billion instructions per second per core with 64 cores. So the chance that an error happens is about 200 errors per second if you calculate this down. So the numbers seem to be that low, but errors happen in IT every second. So, and people don't code for it. And this is also one of the huge problems I see with microservice installations, because people are so used to what we kind of got with SQL, that code in 1970s and transactions. And people curse about AGB and Java Enterprise. But the good thing with all those technologies like transactional in CDI and AGB is that you have the proxies and you have an automated transaction handling, and people kind of not even think about it, but they kind of assume this is granted, that the outermost level kind of opens the transaction, and if something goes bonkers and an exception blows up, there will be a rollback, and then your state is kind of, your database is kind of protected by this.
Okay, so now concretely by overengineering, I just give you an example, and then to transactions. So a typical project looks like this. So for me, I think this is what happens: is they start with JPA, and they create a Java class, and then the IDE generates getters and setters. Then they have lots of getters and setters. They are not needed, but they are already there. They look at the getters and setters like, this is ugly Java. What we can do? So and they find Lombok. So then they add an annotation, getter and setter in Lombok. Now Lombok generates gazillions of getters and setters. Then they Sonar Cube says, okay, we need constructors for every class, which is actually not required in Java. So then they add default constructor annotation on every class, and Lombok generates all the default constructors and whatever. Then they try, to optimize transactions. So, and they say, okay, it's cool. Then we will start transactions, on the database level almost, and the most closest class to the database sometimes starts transactions, sometimes not. Then they disable transactions everywhere else because they guess the transactions are slow, so they do not support it on everything else. And now we have already several problems. One problem is that no one knows what is actually consistent and what isn't. And then they find application scope, the other X inject singleton, and the other X EJB singleton. And because everything is there, they just use sometimes application scope, which does not lock, then EJB singleton, which locks. And then they get funky effects. And so after several iterations, sometimes I get a contract. Then I would like or I should help them with microservices. And what happens is they build such a monolith which looks like a high tech, but is over complicated. And I look at that and we say, okay, let's delete Lombok and all the getters and setters. We don't need it in Java E. And so what I do, I simplify the code, and in the end of the day, we could introduce microservices or not, but the whole code base then is now back to the roots. Simple code, what, as you said, the facades, the EJBs or transactional, they are starting the transaction and the facade level. This is reused, and out of the box, everything is consistent. So there are no tricks, nothing. Simple code. So back to simplicity. And this is the problem I see. And the next danger is, all the reactive programming, asynchronous programming, is the next trouble, because asynchronous is fine in case the user interface is also asynchronous, but in most cases, the interfaces are built in request-response way, so that they have to block somewhere. And if you try to block an asynchronous system, you are already in trouble. You cannot actually, you cannot resolve the errors. And it means that you're absolutely right. All the error handling is actually not in place. There are no timeouts. No one knows, how to react to timeouts. The next problem is there are only technical metrics in place. There are never business metrics, what the system is actually doing. So I would say the most obvious things are not implemented, and everything else which is funky from conferences, the funky frameworks and whatever they have, new programming languages are there, without any added value for the system. I think this is the most problem.
Yeah, a similar experience. People, the transaction thingy, people kind of often do the transaction handling on a kind of too deep level, where they kind of should, if you have a request response or also event, then one event should kind of be a transaction. And then you can overdo it, like have been there with the Spring, what I'm not quite sure if it's introduced by Spring or by Hibernate, the transaction per view, where you kind of have a servlet filter which opens a transaction already.
Open view in session or something like this,
Open
right?
view in session, yeah. And I'm completely with Flat that this is overkill, but it's way too much. But if you do it kind of directly on the DAO, then it's too late, because you call 5 DAOs and then you have 5 transactions, and just if some of them blows up, then the other is already committed, and you also have inconsistent data. So having the right level of transactionality is an important thing to understand. And what I love, especially, it depends on the front-end technology, but especially for JSF projects, I love the request scoped entity manager pattern. You could also do this with E7 and so on, with a transactional on kind of the JSF action. But you even have lazy loading then in the JSF render response phase. For kind of things like if you do Angular or Vue.js applications where you need to send a DTO, kind of a JSON DTO back, then you probably are perfectly fine with AGB or a transactional from JavaX transaction. But you have to apply it on the where the business bracket needs to be, and not on a much lower level. And the reason why I started this discussion now is, if people now move from a biggish monolith, or they claim it's a monolith, to splitting this up in 100 microservices, then we are almost there where we have been with SOA. You have a customer service and an address service, and you have your business logic, and it calls, create this customer to the customer service, and then say, okay, I have 3 addresses. Create address number 1, create address number 2, create address number 3. And all those are REST calls, which are actually most of the time it's not REST, it's just JSON plus HTTP, which is not the same than REST. But you have kind of 4 remote calls, and you don't have a transaction boundary anymore, because these are actually 4 transactions. And if your address service bumps up after the second address, then you have inconsistent data. And this will happen, because you know that Fallacies of Distributed Computing from Peter Deutsch, 1986, Sun Microsystems. They have been there.
Yeah.
We know this since 40 years now. But nobody cares about it anymore.
Yeah.
And they only care about it once they have this in production, 2 years later. Because such data inconsistency failures, you don't see them immediately. Because if the microservices have different databases, well, there is not even a constraint between those things. And you kind of have bills pointing to a customer which doesn't exist anymore or did never exist because, the customer transaction went wrong and boomed up, but the bill has been written. And you figure this after a year or two, if you do some reporting and some database administrator goes completely bonkers and cries for 2 weeks because he can't find anything and everything is broken. And then you start looking at the database and you have to admit this is wrong. And things went really, really bad. And I've seen this in production quite a few times already with microservices.
Yeah. So I'm thinking just because I have two topics still. First, one with the modules. So no modules. So now you understand how my code mostly looks like, what I see. And for me, my approach is simplify as much as possible. And simplify means what will happen usually is we get in 99% of all cases a JAX-RS resource, which I try to be really RESTful, or at least you should recognize if you look at the URI, what happens from the business perspective. Yeah. So this is what I really like. So don't make me think.
This is a huge failure. A lot of companies or a lot of people do not understand that there is a difference between an imperative HTTP plus JSON call versus a real REST resource.
Yeah. So customers get the customers or processes like, cancellations or orders or whatever. So you can just model this way. And then behind that, the JAX-RS resource is never unit tested because it has no code, no significant amount of logic. So cyclomatic complexity, probably 1 or 2. And then behind that,
just runs through to a CDI service.
Yeah. And in my case, it is either CDI, it really depends, or still in most of cases an EJB, but it's almost the same. So it is either stateless or request scoped transactional. So both is almost the same. And behind that, only POJOs are allowed. So there's no more EJBs, nothing. And they are optional. And in some cases, it is good enough that you would just inject the entity manager directly to the facade for CRUD, and you are golden. So in some cases, you end up in my architecture having 2 classes. And in more complicated cases, the facade plus as many POJOs you need. And if you have persistence, you could inject the entity manager directly to the POJOs. Having said that, if you get complicated queries, what will happen is you get one POJO control which just cares about the queries, but it just occurs. So I never write, DAOs up front. It's just they just happen because if you think about the responsibilities, in one point of time you get something like customer search something, and the customer searcher just cares about the search. And this is the basic thing. And now, how to encapsulate the concept. And the encapsulation we have is a microservice. So if this thing grows and it makes sense to have from the business perspective, something like this, which makes sense from business perspective. Let's say we have a customer service, and this is one team which cares about the customer service, and the lifecycle is team dependent. Then we create a war. Now the name is microservice. Back then it was just a war, and we ship it to production. And another team communicates with this war via not type safe interfaces. Exactly what you said. This is like JavaScript-like approach with the modules. But even if in larger projects, I think you end up having at most 10 such microservices because it is.
Yeah, but that's a naming point. Yeah. Well, that's also, I've never seen a big business company with just one monolith application. They call it monolith because it maybe have 2,000 classes or so, but it's actually, there are 10 of such applications talking with each other permanently. And if you go remote, then you kind of have the transactionality inside. But if you go remote, all the guarantees are off, and you have to apply the same algorithms or solution like you do with microservices. But if you have bigger services like self-contained systems, that's the term I use most of the times, per biggish domain, then you only have to care about all those problems and do it yourself if you go remote. But if you stay inside your biggish application, then you still have all the transaction guarantees, and people can just program for the green line, and if something blows up with a null pointer, well, it gets rolled back. Bad luck, but the data is consistent at least. So it's not a case that we are talking about microservice versus dev one monolith for the whole 50,000 employee company. That's never been the case. Each biggish part in the company has its own application, and they are already talking with each other, and so this has always been the case. I've never seen a big company which has just one application.
Okay, then in my approach is to keep the monolith as simple, as lean as possible. And if everyone is happy, so we have just one microlith. And
yeah, it's not just the question is, I don't care how it's called, slicing those things too small, kind of having the medical department and slicing the medical department in 275 microservices. It's just bonkers.
Yeah.
It doesn't make any sense.
No, absolutely not. And this is, yeah, exactly. And it always makes sense if it is obvious. So I in a startup, so I can mention he would love it. So it is what was it? Tippy camp. So this is like tent as a service, and it started with one war, and he was really happy. So this was one person startup. And the problem was the payment, like Airbnb and PayPal and whatever, they changed frequently. And we always had to redeploy his war. And if we identified the problem, we extracted the payment services into another war. And we had war-to-war communication with two independent life cycles. But this was obvious. We didn't care whether the name is microservice or not. It made sense.
Yeah, sure.
Yeah, and this is how I see microservices or whatever, however you call it. So this is for me the ultimate module. And I would expect that such a module has own life cycle and own versioning, And therefore, I don't have modules inside my war usually, because if this grows too big, we introduce another, how we call it, self-contained system or whatever you call it. So it's something like the ultimate module, which only communicates with ASCII with the another Java module. This is the idea.
Mm-hmm. I just recently got asked by a company colleague, where do I see me in 5 years? And I said to him, well, I expect that we are all re-engineering microservice projects into something else, because people will figure that they kind of overdo it and cut those things way too smallish. You should always only cut things into parts if it's needed, or it will be needed.
I think it was more than 10 years ago. I got asked by a German magazine, it's like Manager magazine or something, what is my opinion if SOA, the SOA, takes off?
Yeah.
There will be many layoffs, and what the people will do afterwards. And my answer was, if SOA will take off, no one will be jobless, because the system gets so complicated that we will have to double the workforce. And the writer, the editor of the magazine, they didn't want to publish that, and they said, don't change it. You will have to publish this in that way. And they published it, but it was a huge circus, because they were really no, this was not what they wanted to hear.
Yeah, sure.
Yeah, and this is the same
but
right now.
True.
This is completely over exaggerated. Everyone creates microservice, and I asked them, what is the purpose of the module you wrote right now? And there's usually no answer. They just wrote because they think if the more microservices they deploy, the better it gets.
Yeah, but there is something like with SOA. Everybody hates SOA now. Back in the day, they was raving about it.
Yeah.
But there have been a few kind of patterns which evolved and which are still in use. Like the whole Saga pattern is based on compensations. Compensations got basically not introduced, but made kind of the publicity aware with SOA. And so we have the same with microservices.
Yeah, but
things
these compensations are trivial if you think about this. The problem we have always, no?
Yeah, but they don't do it. They don't do it, and it's hard to do it right, and you have to do it right for every single functional call you do, and it's always different. It cannot be automated, and people have to think about it, and they forget about it every second time. In practice, compensations are almost never really okay, except you really have them often. Blowing up.
My criticism to all that is microservice. There's a new term, everyone is confused. Then compensation. So compensation means basically, so if the transaction commits in a database and you roll back the transaction, it usually does not happen in real world. So if you ordered something, and the order is on the way, you cannot just say roll back and the order disappears magically. Yes. So you will need another transaction which sets off, this compensation means you have more and more transactions. We try to compensate whatever happens in the past, and the problem is it gets more and more complicated. And and this is why these trade-offs is if you write simple code, request, response, synchronous code with and this understandable, you will win. And whatever we talk about right now, there are already solutions to problems. If your system had another problem, like, they had to distribute the system, or you did something strange with it, or you are Netflix, so that you have no other chance. So my basic advice is you are not Google, Facebook, or Netflix, and then forget about them and do whatever you have to do to solve the problems. So by the way, are you actually aware of the Jeff Bezos note on microservices?
No, I'm not quite sure.
It was in the year 2002, and my idea was to start our conversation with that, but it got too interesting with your approach to testing and modules. So I think, okay, forget about microservice for a while. And the note is, I will just read it, and I put it to the show notes. So Jeff Bezos wrote a mail to all the employees in 2002. This is how AWS happened. And it said all teams will henceforth expose their data and functionality through service interfaces. This was first thing. Team must communicate with each other through these interfaces. There will be no other form of inter-process communication allowed. No direct linking, no direct reads of another team's data store, no shared memory model, no backdoors, whatever. The only communication allowed is via service interface calls over the network. It doesn't matter what technology they use. All services interfaces, without exception, must be designed from ground up to be externalizable. This is to say, the team must plan and design to be able to expose the interface to developers in the outside world. No exceptions. And then the last sentence in the mail was, anyone who doesn't do this will be fired. Thank you. Have a nice day. And interesting is 2002. And why Amazon did it, because what Amazon does, it reinvested all the money back to development. And with that approach, they implemented business logic double and twice, but it didn't matter if they move faster. So they had endless resources, and they could parallelize their work. It was complete different mindset than my clients have. If I would say we just start, 500 teams, and we will do, 100% of the business logic will be duplicates, but we will move faster. And it will cost twice as much, but we will be 30% faster. My clients will say to me, "You are fired." This is complete different world, and so microservices have different advantages. So what I think what happened over time is the idea back then from Netflix on Amazon, it does not apply at all for businesses. But if we separate, if we isolate the processes, we do it reasonable. We have complete, different advantages. So where Amazon is not interested in, for instance, right?
Yes, the standard business has a benefit in modularization, doing proper modularization. Amazon, Netflix style of things, they barely have transactions. They are mostly about throughput and scalability. And for each of those, you have different trades-off. But I want to quickly come back to what I started earlier. The benefits of microservices will be there even in many, many years, even if we don't do microservice type of architecture anymore, because there are so many tricks with the broad public learned, like circuit breakers, like correlation, log correlation, and kind of traceability over different systems. The same applies. Of course, in microservices, you need it for almost every call, because you're going remote every time. But the same applies if you have kind of self-contained biggish monolith systems which talk to each other, or like a SAP or a document archive or whatever. So whenever they kind of leave their transaction safety inside world and go remote to somewhere, then it's really good to also have a circuit breaker, to a bulkhead or whatever. So there are a lot of patterns we can learn from the microservice architecture idea and apply them also to monoliths, because it's not a problem of microservices. It's a problem of going distributed.
Yeah, absolutely with you. So this is why everything repeats, If you learned 20 years ago Genie once and you knew what problem you had, you could still, what I really do, I still steal, the Genie ideas in my real world project, like leasing. You know what leasing was back then?
Resource leasing.
Yeah. This was like a service had to say, I'm alive. It wasn't. It was, it disappeared from the network. Genius idea, yeah. And so I think the challenge is not to forget things, So if you learn once the basic host technology, mainframe technology, you are good for microservice and clouds, I would say.
Yeah, the problem, as I said, the fallacies of distributed computing got introduced or written down in 1986, and they still apply. And so
to close the discussion with a short, with a new topic, what's your opinion about Big Bang Jakarta migration?
I brought this up a year ago or so, and I think it's the only reasonable way to do it, because it can be automated on the bytecode level. Right. So you can drop in an old war, and I wrote a prototype of this yet, and I have a student which works on it. And
well, cool. You have students who work for you.
Yeah, they do bachelor thesis or something like that.
Hey, cool.
And they're looking in things which are useful, and I kind of have many real world problems which are also interesting on this. And one of the things, and they end up kind of being open source projects at Apache or so. One of the current things is to have a class loader or bytecode retransformer, which kind of, if you load an old war file with javax.inject or javax.faces something, it will kind of dynamically rewrite all those things to jakarta.faces.something.
Yeah, cool.
On the bytecode level. That's not that complicated. We've done this before, but you can automate this. And of course, there are resources. You have to think about the service loader. So in detail, it's a little bit more tricky, but it's a neat thesis, I think, and some good kind of point to get into bytecode level Java.
So I'm also with you. So I think from different perspective, if we have a Big Bang Jakarta EE migration of the namespace of the packages, it is extremely good for marketing and for future developers, because they see, okay, this is the new stuff, and we have do not care about the JavaX. And I got also another benefit could be we don't have to migrate everything over. What I will do, I would, for instance, make
it could
SOAP.
Be a Java plugin, a Maven plugin.
Yes, for instance, SOAP. I wouldn't deprecate SOAP. We could talk about deprecation of EJBs if we have equivalent. We get equivalent stereotypes on CDI. So something like request scoped and transactional could be grouped into something like service or whatever into one stereotype. So we don't have to pull over EJBs, and schedules could be standardized. So if we migrate over the functionality to CDI, We could drop EJBs.
Yes.
We could drop, the old XML RPC and whatever is there. So I wouldn't migrate it over. It's also your opinion that, for instance, Jakarta E9 could be a much leaner because then what the service could do, you could work with your legacy stuff, having Java X, WS SOAP or whatever, and the new stuff would be Jakarta E, right? This could work that way.
Yes, and with bytecode tricks or class loader tricks, you can even run old jars and import it. Of course, if you compile against it, then you have to might be tricky in the detail, but it should actually work to do this on the fly even.
Okay, cool.
Or with a Maven plugin.
And what's your opinion about the micro profile in Jakarta E? So from my perspective, they should be kept separate. So because the iterations of Jakarta E is slower, this is like major boring technology, and this is micro profile is like driven by Cloud Native Foundation and the cool stuff which we cannot control. So they iterate faster. They have 4 releases a year. So I think it's a good idea to keep them separate. What's your opinion on that?
The spirit of the teams is completely different. Even if there are sometimes the same people involved, but the microprofile spirit is much more open source, ready, where and much faster moving, and where the Jakarta spirit is still the Eclipse Foundation has to free itself from this old thingy, from this old thinking. And this is gets apparent with this CLA change, which is from a legal aspect completely useless. It just stopped half of the contributors to contribute because it was additional legal barrier, and it's so useless.
Okay.
So I think Eclipse makes its living right now a little bit harder than it needs to. Mm-hmm. But I'm pretty confident that at the end of the day it will get sorted out, and we will start moving fast again.
So it means you are also for keep them separate, microprofile and Jakarta?
Yes.
Oh, very good. So this is in the rare cases where we agree on something. This is actually amazing. So we never agreed.
It's not that rare cases, but we are so often approaching the same goal from different angles. That's
but
the
complete
point.
opposite angles. This is the interesting, because sometimes I don't know, I listen to something from you. It's like, what you are talking, it's just crazy. and then I thought about this. Is actually I could end up having the same thing from complete different direction.
Yes, I remember we had a talk once at the conference where after you gave your talk, I said, "Hey, come on, man, this sample doesn't work in production or in practice because that and that and that." And your answer was basically, "So yeah, you're right, and I know this, but if I would have explained all those details, then people would completely lose me." Mm-hmm. And so it's you go to companies and do the spike, and you bring them to the right direction.
Yeah.
And this is really good, but you don't often have the time to start with all the details, I guess. And I'm coming from the completely different angle. I start with all the details, and then after an hour of talking and losing 80% of the people, probably, I explain them why I explained this to them.
I have two kind of projects. One kind is the spikes, and the other one is what you are doing are firefighting projects, and then it's just about the details. But I don't have nothing in between. So I think for 10 years I never spent more than a month in a project. So it's just like I don't stick with a project for a long time. Either I see the disaster, I try to fix it, or they ask me, how an ideal architecture would look like, and we work together, and then when everyone is happy, then I leave the project usually, and then they do whatever they like to do, and then they keep inviting me once a month or whatever, and then I try to help them or answer questions or something like this. So this is what usually happens with me. Mm-hmm.
I have a definition of my personal definition of done, because I got this asked a few times because people think yeah, cool, you did the architecture, you explained us how we do it, we're fine, project finished. I said, no, a project is finished after it runs in production for 3 months, and the users are happy. It's not about you, the customers are happy, that the people who pay me, I completely don't care about. The people who have to use those programs, they need to be happy. And you really see this only in production. You could have such a good feeling, and then people come to you and the clerk people and say, oh gosh, this is completely contrary to what we do in practice and what we need. And well, then you're not finished.
Cool. So we covered a little bit microservices, but the discussion was more interesting than I actually assumed, because we covered the modules, which so we should do another follow-up in half a year or something and talk really about microservices or serverless or whatever if you're interested in it. And where people can find you, you can give some links to your internet resources.
Of course, on Twitter or at Apache, Struberg at apache.org, or
Perfect.
So, or Struberg at Twitter and so on. And I don't think we will be talking that much on microservices in 2 years from now. And for me, microservice is just a name for another flavor of distributed architecture.
The cool story is I also did some talks. I do a lot of projects with JavaScript, plain JavaScript. And in one talk, I hacked something and someone said, what you are proposing here, it's called micro front ends. So cool. And the next talk, Java user talk, I will rename the talk to micro front ends. So now I learned a new term without.
Now I have an interesting question. How do you do front ends for microservices? Because that's something I really struggle. We have a lot of customers which do Angular or Vaadin, and a few of them are still doing JSF. And what I figured is that JSF is such a much better fit for microservice or kind of monolithic backends where you have multiple application server, but still you need to have kind of appear to be one UI. Yeah. Because if you
I have to stop you once. One question. How much time do you have now?
I have enough time today.
Okay. So we stop this episode and we do right now in 1 second another one about this topic. Agreed?
Okay. But I can't add too much.
So we say just bye.
For the answer. Okay. Have a nice afternoon. Thanks you for the interview. Ciao.